This lesson is on inverse functions. The function obtained by switching the x and y variables in a function. The inverse of a function f is written as f to the negative 1. The new relation obtained by reversing the x and y values of a function is not necessarily a function itself. The new relation is only a function if the original function is 1-to-1, and that means it passes the horizontal line test and the vertical line test. So when you look at it, and we'll discuss it in our last exercise, it has to pass a horizontal line only touches once and a vertical line only touches once. So consider the two linear functions given by the formulas f of x and g of x. Calculate f of 5 and g of 11. So f of 5 is going to be 3 times 5 plus 7 divided by 2, which is 11. G of 11 is 2 times 11 minus 7 over 3, which is 5. F of 5 is 11. G of 11 is 5. What does that mean? Let's look at that. 5, 11, 11, 5. What did we just do? All right, so now let's try to calculate f of g of negative 1. So we're going to start with g of negative 1. So 2 times negative 1 minus 7 over 3 is negative 3. So the answer to g of negative 1 is negative 3. So now we're going to do f of negative 3. So 3 times negative 3 plus 7 over 2 is negative 1. So f of g of negative 1 is negative 1. Weird. All right, last one, f of g of 5. I wonder if something's going on. So g of 5. So 2 times 5 minus 7 over 3 is 1. So this is 1. So we're doing f of 1. So 3 times 1 plus 7 over 2 is 5. So f of g of 5 is 5. So what happens, or what does it mean, when you do a composition of a function and you end up with the exact same thing you started with? You end up with x. Well, the two functions seen in exercise 1 are inverses because they literally undo one another. So when you perform a composition and you end up with what you started with, you end up with x. So that's what this is saying. They are inverses. So a long time ago, you learned about the domain and the range. So remember, the domain is x. It becomes the range of the inverse. And the range of the original becomes the domain of the inverse. Why? Because we're switching x and y. So way back up at the top, this idea of switching the x and the y variables, that is the idea behind an inverse. Of course, it could never be that easy. You got to do stuff with it. So some of your questions will be to write the equation of an inverse. Okay? So how do we find the inverse? Well, step 1. Switch x and y. So we get x equals 3y minus 2. Step 2 if it's an equation like these are, get y alone. So how do I undo the two things that are attached to y? How do I undo multiply by 3 and subtract 2? Well, what do I do first? I add 2. And I divide by 3. If you need to show multiple steps, go for it. Next one, a little bit more difficult. Switch x and y. X equals -2 divided by y minus 5. Now, how do I get y alone? Well, I have to undo divided by y minus 5, so I'm going to multiply by y minus 5. So I have x times y minus 5 equals -2, because these undo each other. So I have xy minus 5x equals -2. How do I get y alone? Well, I need to undo the negative or subtract 5x. So xy equals -2, add 5x. And then I need to undo multiply by x, so I'm going to divide by x. Do not divide those two x's out, because there are two terms on top. You need to divide both of them by x. Well, it doesn't go into the -2, so my answer is y equals -2 plus 5x all over x. That is the inverse. Now, one of the things that we're going to look at is what does it look like graphically? This is a great way to check your work. So exercise number 3 gives us a table. And they tell us the function x squared, which is a parabola. So how, do we find the table of the inverse? Well, we switch the ordered pairs. So x becomes y. So we have -2, -1, 0, 1, 2. And y becomes x, 4, 1, 0, 1, 4. Now we'll graph them. 4, -2, 1, -1, 0, 0, 1, 1, 4, 2. It's a sidewards parabola. Now let's talk about a few things. The original is a function, so f of x is a function. How come? It passes the vertical line test. So if I draw any vertical line, it only hits the graph once. The inverse is not a function. Because again, if I draw a vertical line, I'm not going to hit this graph once. I'm going to hit it multiple times. So now they want us to write the equation of the inverse. So we're going to switch x and y. Well, f of x is the same as y, so y equals x squared. So x equals y squared. How do I undo squared? It's the square root. Well, here is our problem. So grab your calculator. When we graph the square root of x, we only get the top half of the parabola. Hopefully you're thinking, wow, that's the positive half. So if we hit tab, and we hit negative square root of x, we get the bottom half. Well, each piece, if I only had the blue one, that would be a function. If I only had the red one, that would be a function. So in order for me to make the inverse into a function, I would have to restrict the domain. I would have to say only graph the positive part or only graph the negative part up here in the original table. If I only graphed -2, -1, and 0, that would be a function in the inverse. If I only graphed 0, 1, and 2, the same idea. So the big thing I have to remember down here is when I introduce the square root in the problem, I need a plus or a minus. That's the only way for me to get this entire graph. Okay? Now, the other thing we need to know is if I want to check and see if something is an inverse, I can look at the ordered pairs and they should be swapped. XY should go to YX. So -2, 4 goes to 4, -2. -1, 1 goes to 1, -1. That's a great way to check if they are inverses. The other way is to look at the line y equals x. If your graph is a reflection in the line y equals x, they are inverses. And you should be able to see that if I fold along that dotted line, those two graphs, those two parabolas, are on top of each other. Therefore, they are inverses. So lots of ways to check your work. So on the two equations we did in exercise 2, we could graph them and make sure that they are a reflection over that line, or we could check the tables to make sure that xy became yx in the inverse. If you have any questions, don't hesitate to ask. Good luck.